Okay, Unit 6 review packet, topic 17, graphing rational functions. Sorry, I started and had some technical problems. So, looking at this first one, we always check to see if we can factor either the numerator or the denominator. In this case, we can factor a GCF of 4 from the denominator. Then we find our asymptotes. My vertical asymptote is based on what makes my denominator 0, because we can't have a denominator of 0 because we can't divide by 0. That's undefined. So in this case, if I put 5 in here, 5 minus 5 is 0. 0 times 4 is 0. My denominator is 0. That causes a problem. That's my vertical asymptote. So make sure when you draw it vertically. Write it as an equation. X equals 5. That's saying x is 5. And that's a vertical line that goes through 5. My horizontal asymptotes depends on what kind of rational function I have. So a memory tool to help with this is Bobo Botan Eats DC. So this stands for bigger on bottom, 0, bigger on top, none, and Eats DC is exponents are the same, divide coefficients. So if I look here, I can see in this first example that my exponents are the same. So I'm going to divide the coefficients. So my coefficient of x is 1. This coefficient of x is 4. So I have 1 over 4. That would be right about here. And that's my horizontal asymptote. I then like to graph before I actually find my domain and range because I like to look at the picture. So we're going to put this in our calculator. So under y equals, and if you're not going to use alpha y equals enter, you do need to put these in parentheses. If you use alpha y equals, you don't need to worry about the parentheses. And I go to my table, and I'm pretty much looking for where the vertical asymptote is. So I want at least 2 values above and 2 values below. So there's my vertical asymptote. It says error because it's undefined. So let's see if I can find any whole numbers or integer numbers. No. All right, so we're going to go with, we'll say 2 and 1/3, 4 and 1/2, 5 is undefined. This is my vertical asymptote. 6 and 0, and 7 and 1/8. So when I plot these points, I've got 2 and 1/3. So this one's, think about 1/4 and 1/3, right? So 1/3 is actually bigger than 1/4. So I know it's hard to accurately graph on this, but it is above my horizontal asymptote. So I'm here at 2 and a little bit above, and then I have 4 and 1/2, 6 and 0, and 7 and 1/8. So I'm going to have one curve like this, and, oops, 1/8 is up here, and one curve like this. And I should always check on my calculator and make sure it looks like my calculator. Let's see, window 6. So now my domain. Well, if I look here from left to right, I see that the problem with my domain happens here at the vertical asymptote. So I start at -infinity, but then I stop here because I'm not touching this vertical asymptote. We can't cross vertical asymptotes. So I'm stopping here. This is at 5. It's parentheses because I'm not including it. Then I start up again at the vertical asymptote and go to infinity. Now for my range, I'm going from down to up. Now you can sometimes cross horizontal asymptotes. However, in this case, we didn't cross it. So we come up and we stop at the horizontal asymptote, which is at 1/4. And then we start up again at the horizontal asymptote and go to infinity. My end behavior, you can either look at the graph to determine it, or end behavior is based on your horizontal asymptote. That's what it approaches. So as I go to the left toward -infinity, it's approaching my horizontal asymptote. As I go to the right, it's also approaching my horizontal asymptote. And there's the first one. All right, so my second one, number 24. Again, we always want to factor first if we can. So to start off, I see this has a GCF. So I'm going to divide everything by 2. And then I'm going to factor two numbers that multiply to be -8, that add up to be -2 would be -4, +2. Down here, this is the difference of squares, x plus 3, x minus 3. So now I have more than one vertical asymptote. I always look, the nice thing about vertical asymptotes is it's always what makes the denominator 0. Whereas horizontal asymptotes, you've got to think, which kind is it? That's the Bobo bot and eats DC to help you remember. But vertical asymptotes, what makes it 0? Well, I have two things. -3 would make it 0. The other is 3. So I have x equals -3, x equals 3. So my vertical asymptotes, I've got one here at 3, and I've got one here at -3. My horizontal asymptote, if I look to see what kind this is, Bobo bot and eats DC. I'm looking at my exponents. This is eats DC. Exponents are the same, divide coefficients. So again, my coefficient here is 2, my coefficient here is 1, 2 over 1 is 2. So that's my horizontal asymptote. And now I'm going to get some points from my calculator. So y equals, alpha y equals, enter, 2x squared minus 4x minus 16 on the top, x squared minus 9 on the bottom. So let's make a little table here. Now I've got two asymptotes, so I'm going to need some points above, below, in between. I've got multiple ones, so I'm going to need more points on this one. So I've got, let's see, -7 and 11/4. I have -4 and 32 over 7. This is my asymptote, undefined, so that's one of my asymptotes. -2, 0, -1, 5/4, 9ths, 1, 9/4, 2, 16/5. I'm putting a few extra points in. You don't normally need quite this many. 3 is undefined again. That's my other vertical asymptote. And then 4, 0, and 5, 7/8. All right, so let's start plotting some of these points. So 11/4 is going to be not quite 3, but close to 3. So -7 and 1, 2, almost at 3. 32 over 7 is going to be about 4, a little past 4.5. So -4, 1, 2, 3, 4, kind of and a half. And then I've got -2, 0, -1 and 5/4. So that's a little bit above 1. 0 and 16/9. So 16/9 is close to 2. So, but not at 2. 1 and 9/4. So this one's going to cross, because 9/4 is a little bit bigger than 2. So I've got 1 and a little bit past 2. It crosses the horizontal asymptote. Remember, you can cross horizontal asymptotes. You can't cross vertical asymptotes. And then 2 and 16/5. That's kind of close to 3, a little bit past 3. So 1, 2, 3. And then 4, 0 is here, and 5 and 7/8 is close to 1. If you're not sure what it looks like, I would hit graph first and look at your graph as you connect your points. So this one, if I look, this is my one we've kind of been doing a lot of, the curve that approaches both. And the same thing down here. My curve is approaching the vertical and the horizontal. But then this middle section, right, I have this, it goes up, I have this point of inflection, and it keeps going up, and it crosses. So it's going to be down here, going up, and continuing. And always use your calculator to check and make sure that you've graphed it right. It's a really quick, easy check. So there's my picture. So now my domain. My domain's a little trickier because I have more than one vertical asymptote. If I look at the picture, I start from the left, I stop here. Then I start up again, stop here. Start up again, stop here. So I start at -infinity. I stop at my first vertical asymptote of -3. Then I start at negative 3 and go to my next vertical asymptote of 3. Then I start at 3 and go to infinity. Now my range on this one, because I'm crossing the horizontal asymptote, there are no y values that I'm not including. I start from negative infinity and I continue all the way to positive infinity. There's nothing that my y value can't be. And then lastly, my end behavior. As I get farther and farther this way, it's approaching that red line. That red line is my horizontal asymptote, which is 2. And the same thing as I go this way, it's approaching my horizontal asymptote, which is 2. So there is the number 24. All right, let's try number 23. So on this one, again, I look to see if I can factor. Down here, I can factor out a 2. Nothing else. So my vertical asymptote is what makes this 0. Well, negative 2 is going to make my denominator 0. So x equals negative 2. My horizontal asymptote, I need to be thinking Bobo Botan eats DC. Well, my exponent on the bottom is bigger. So that's Bobo, bigger on bottom. That means it's 0 for this part, but then I need to add this 3. So this is 0 plus 3. My horizontal asymptote is 3. So now let's graph these. I've got x equals negative 2, y equals 3, and we're going to get some points off of our calculator. So we're going to go to y equals and put in alpha y equals enter, negative 1 over 2x plus 4 plus 3. Oops, plus 3. Go to my table. I want at least 2 above and 2 below. So I've got x, y. Doesn't look like I'm going to have any great ones here that are not fractions, but all right, so we can do negative 4 and 13/4, negative 3 and 7/2. Negative 2 is my undefined. That's one of my vertical asymptote, or that's the only vertical asymptote. And then I have negative 1, 5/2, and 0, 11/4. So let's graph those. So negative 4, 13/4. So 1, 2, 3, 4. It's a little bit past 3, right? Because 4 times 3 is 12. So we're going 1, 2, 3, just a little bit past. And then negative 3, 7/2. That's 3.5. So 1, 2, 3.5. So this one's going to be like that. And then negative 1, 5/2. So 5/2 is 2.5. So 1, 2.5. And 0 and 11/4. So 11/4 is close to 3, but not quite. So we're here. Okay, so there's my graph. And again, we check it on our calculator and make sure it looks like the same graph on our calculator. So now my domain. If I start from left to right, I start going, I stop here. So I'm starting at negative infinity, I stop at the vertical asymptote. Then I start back up at the vertical asymptote and go to infinity. My range, I start from down here, from negative infinity, I stop at the horizontal asymptote. Then I continue on with the horizontal asymptote to infinity. And my end behavior, in both directions, it approaches the horizontal asymptote, which is 3. All right, last question on this page. 25. So, let's see, can we factor? Yes, we can factor an x out here and a 2x out here. So that gives me x plus 3. So first of all, my vertical asymptote, what makes it 0? Well, I have 2 factors, so I need to set both of them equal. So in finding my vertical asymptote, I'm saying 2x equals 0 and x plus 3 equals 0. This gives me x equals 0. This gives me x equals negative 3. So I have x equals 0. Oh, you know what we didn't do first? We didn't cancel. Sorry, go back. I was too fast. Right after we factor, we always want to look to see what can we cancel. Can we cancel anything? And guess what? In this one, we can. Top and bottom both have an x. That means I can cancel the x and the x, which leaves me with x minus 3 over 2x plus 3. There we go. Now I only have one vertical asymptote. It's only where x plus 3 equals 0 or x equals negative 3. So not there, but x equals negative 3. So don't forget, don't do what I did. Don't forget to cancel before you find your asymptotes. All right, my horizontal asymptote. Bobo ba and eats DC. Let's see. This is eats DC. Exponents are the same. Divide coefficients. So if I divide coefficients, I have 1 divided by 2, or 1/2. So let's put in x equals negative 3. It's my vertical. My horizontal is at 1/2. Okay, and let's get some points. Now, there is going to be a hole. So a hole is basically where I would have had a vertical asymptote, except that I canceled. So if you look here, I canceled these x's. And I got this. But I still can't have x equals 0 because this is my equation. And if x equals 0, my denominator is 0. So I have a hole at x equals 0. And when x equals 0, you can find y by putting it back in here. So 0 minus 3 is negative 3. 0 plus 3 times 2 is 6. So negative 3 over 6, or negative 1/2. So this is my hole. So at 0, negative 1/2, there is a hole. All right, so now let's find some points and get a table going. So x and y. So y equals, we're going to do alpha, y equals enter. And I've got x squared minus 3x over 2x squared plus 6x. And I am going to use 2 above and 2 below. So I've got negative 6 and 3/2, negative 5 and 2. And then at negative 3, this is my undefined spot. This is my vertical asymptote. And again, I have a hole here. So I'm going to put that in 2. I've already graphed it, but there's a hole right there. But I need 2 more points. So negative 2, negative 5/2, negative 1, negative 1. So I'll make my hole a little more obvious when we do it in green. So I've got negative 6, 3/2, so that's 1.5. So negative 6, 1.5. And I've got negative 5, 2. So here's this side of it. And then I have negative 2, negative 5/2, so negative 2.5. Negative 1, negative 1. And again, this is my hole right there. So there we go. So this right here is my hole. All right, so now my domain. Well, I have 2 issues now. I have the issue with my domain stops here, but it also stops at the hole. So I start it from the left, and I stop when I get to my vertical asymptote at negative 3. I start back up at negative 3, but I have to stop when I get to my hole, which is at 0. And then I start up again at 0 and go to positive infinity. My range has the same issue. I'm going to be stopping at the hole. So my range, I start at negative infinity, and I stop right here. And that is at negative 1/2. And then I get going again at negative 1/2, and I stop at my horizontal asymptote, which is 1/2. And then I continue on to infinity. So again, my domain, I started from left to right, started from negative infinity, stopped at my vertical asymptote. Started here at my vertical asymptote, stopped at the hole. Started at the hole, went to infinity. Same thing with y. Started at negative infinity, stopped at the hole. Started at the hole, stop at the horizontal asymptote, start at the horizontal asymptote, stop at infinity. And again, my end behavior is my horizontal asymptote. So that's the last graphing one on this page. So let's look at the back. Which function matches the graph? Okay, so right away, I can see a quick way to do this is look at what your asymptotes would be. This has an asymptote of 6, right? That's what would make this. So this has a vertical asymptote of 6. This has a vertical asymptote of 5, vertical asymptote of 4, vertical asymptote of 3. You could also put these in your calculator and see which one looks closest, but I think they're all going to be pretty close. So 1, 2, 3, 4, 5, 6. Definitely not this one, because this, so this one right here, 1, 2, 3, 4, 5, 6, it would be right here, and that's definitely not the right one. So let's try 5. So 5 is right here. That one looks like it could be it. Let's look at 4. 1, 2, 3, 4. Definitely can't be 4. 4 is going right through, so it's not 4. And then my last one, let's see where 3 is. 1, 2, 3. Yep, can't be that one either. So yes, my answer is vertical asymptote at 5, which is C. All right, last one. What kind of family does each graph belong to? So hopefully you guys have in your head what some of these are. For example, when you see a parabola like this, hopefully you're thinking quadratic. Here's another parabola, quadratic. The ones we just did, rational function, right? Curve here, curve here. Same thing here, rational function, curve here, curve here. And then these right here would be square root, not cube root, because remember cube root has that little kind of point of inflection. So this one, square root, because it cuts off at a point and then continues. So there's the last part of the review packet.